Hello, algebra students. Well, today we're going to look at dividing a polynomial by a monomial. Now, we've looked at multiplication of polynomials times each other, and of course addition and subtraction as well. So we've done everything but division. And division's a little more complicated, so that's why we start with dividing by just a monomial. We will divide by polynomials that have more terms, but we're going to save that for later. For now, we're dividing by a polynomial that just has a single term. That is, we're dividing by a monomial. So how do we do that? Well, we just divide each of the terms in the polynomial by that monomial. Okay, divide them individually, and they are then added together. So we take the first term, 2v to the 6th, divided by the 10v squared. Okay, and add, and we add because this is adding. If that was subtracting, we would subtract, of course. Okay, so we have the next term, 4v to the 5th over 10v squared. And the last term, 50v to the 4th over 10v squared. So now we just simplify each of those using the rules of exponents and so on that you've learned, that you used on the last graded review. Simplify each of those terms. Okay, so the numbers you just divide, and in this first step, we're just going to, we're not going to go ahead and simplify that 2 over 10. We're just going to separate it out. We'll deal with that in the next step. But it will be 2 divided by 10. Okay, and with the variables, you just subtract exponents, right? When dividing, subtract exponents with like bases. So our base is v for both of these. So we subtract the exponent, and that gives us v to the 4th. Okay, 6 minus 2. So the next one, the 4 divided by 10, will be dealt with, separately. We will calculate that, or reduce it, that is. And with the variable, take the 5 minus 2, subtract exponents, and that's 3. And the last one, we have 50 divided by 10. Well, let's just go ahead and simplify. That's 5, right? And for the variable, v to the 4th divided by v squared, subtract exponents. And so the exponent that we have is 2. 4 minus 2 is 2. So that's just about it. We will go ahead and reduce those fractions now of numbers. 2 over 10 is 1/5. Okay, so that's 1/5 v to the 4th. 4 divided by 10 is 2/5. So 2/5 v cubed. And then we had here, we already simplified actually, 5v squared. Okay, and that's finished. That is each of those individual fractions has been simplified and reduced all the way. And so that's our answer. Okay, so let's look at one more. So this is similar. We have a polynomial divided by a monomial. We take each of those terms and divide it by the monomial. Okay, so the 9x cubed is the denominator of each. Okay, we divide each of them by it. And then we simplify each of those fractions. Okay, so the first one turns out that's 9x cubed divided by itself, right? So that is 1. The next one, we're going to have if we look at the numbers, it's 3 divided by 9. And with the variable, we subtract exponent of the like base. The base is x, of course, for both in the numerator and the denominator. So subtract exponents, 2 minus 3, that's negative 1. Okay, and then the last one, 27 divided by 9 is 3. Subtract exponents. Remember, this x has a 1 here. If there's no exponent at all there, that means there's really a 1. X to the first power, it means the same thing as x. Okay? So don't forget that. So that 1 is there. You can go ahead and write it down if you want to. Okay? So 1 minus 3, that's our subtraction. We have negative 2 as the exponent. Now let's go ahead in the next step and reduce that fraction. And with our first term, there's nothing to reduce. The second term, that's 3/9, so that's 1/3. And then the last one, nothing to simplify there. So we've done everything that we did in the first step, but we're not done with this one. I mean, that everything we did in the first example. Okay, we got to this point in the other example and we were finished because we had the fractions reduced and everything was simplified as far as it goes. But on this one, although the fractions are reduced to lowest terms, it's pretty much simplified. The thing about this one is we have negative exponents here. And usually you want to write these without negative exponents. So we have one more step. To get rid of the negative exponent, remember, you put that variable in the denominator and make the exponent positive. And you do that because x to the minus n is the same thing as 1 over x to the n. Okay, that's what negative exponent means. So you put it in the denominator and make the exponent positive. Okay, so let's do that. The first one, of course, doesn't have any variables. It's just 1. Then we have 1/3 x to the negative 1. Well, the 1 over 3 is still what it is. It doesn't change. 1 is in the numerator, 3 is in the denominator, but now we have something else in the denominator with that 3, and that's our x to the first power. Usually we do not go ahead and write the 1. It's right there. I'm going to erase it, but that's where it would be. You could write it, and I won't count it wrong, but usually we don't. Okay, so then our last one, we have the 3, and in the denominator, we're going to have x to the second power, right? Because in the numerator, it's x to the negative 2, so in the denominator, it's x to this 2. That is x squared. So we'll write the 3 in the numerator like this, make a fraction bar, and x squared down there, positive 2 in the denominator because it was negative 2 in the numerator. Okay, and that is it. So that's a couple of examples of dividing a polynomial by a monomial. Stay tuned for more division later.